My name is Kumar, and I'm a business development manager with Intel Corporation. And I will be talking today about end-to-end video analytics solution optimization for securing high-value assets using Intel COFLUENT technology for IoT. So here is a legal disclaimer. I want to make sure whatever material we are talking, this is protected by this disclaimer. So let's talk about it. What is high-value asset first? So how the high-value asset may include your buildings, people, machinery, equipment, and etc. What does securing mean? What you are securing or surveilling? Securing means that you want to detect intrusion. You want to make sure that the things which are there, they are in place, they are operating correctly, they have been used correctly, and there is no anomaly. So surveilling also includes that you are monitoring the facilities, making sure everything is running fine. So we'll talk about that. Here is the agenda. Video camera had been a traditional way of surveilling and monitoring the things. We'll talk video as an eye of IoT. We'll talk about video analytics solution, how the solutions look like, because with analytics you can do much more. Previous cameras, you just monitor, you just see, and you don't know that if there is an intrusion or not. You can't, sometimes you have to zoom in, zoom out, and if operator is there in control room where there are about 10 screens, he will blank out after some time. If there is something going wrong, he may not be able to detect. So video analytics solution with analytics, this makes it really very easy. If there is an anomaly, it will alert the operator, and operator can take action. If there is something incident occur that can tell why it occurred, it has all the trace of it. And if there is something which they can do, it can help in preventing it in future. So we'll talk about video analytics solution, its usages, its challenges, and one of the difficulty comes when you're implementing video analytics solution from edge to the cloud, how to balance the resources. What kind of workload should be done? Where, if it is AI, what pieces of AI should run on edge, middle, cloud, and other places. So that's a big challenge. Then what platform to use? What technologies to use? What kind of storage we should give? What should the speed of network? What should be the buses? And what kind of OS should be used? How heavy loaded it should be, or other things, right? So this is the main challenge, right? So to solve those challenges, to understand how to balance the workloads, what platform to use, what technology to deploy, one of the best way we think is to model and simulate. Like we model and simulate every piece of equipment or piece of outfit which we design, whether chip, machine, airplane, or anything, we do the same here. And the technology which we are using for this is called Intel COFLUENT technology. It's now about a decade old, and we will talk about it. What is the technology, what its benefits, how it can be used, and then we'll talk about the video analytics platform, how to use, what it can help, and this will be a case study. And then we'll talk about a generic library which we have generated for end-to-end model for IoT system, and which can be used by any customer or anybody to create their model quickly and balance. And if time permits, I'll go through other COFLUENT platforms which are SOC and big data. So let me move on to the next segment. Let's look at the focus, why we focus on video. There are too many things to do in the video side. The market is huge. If you look from simple residential area where you are just securing and monitoring, that nobody is intruding, or the children are safe at home, to the healthcare where you want to monitor your patient. How is he doing, and is he okay or not? That's thing, or the equipment around the patient is all right. Next is the financial services area, where you want to make sure that everything in the financial bank system is working fine. In retail store, you want to see where the customers are going, what they're purchasing. In industrial area, you want to make sure your equipment and production is running in fine. There is no intrusion. There is no unnecessary person on the floor. And then, or also safety in industrial area, where you can monitor it or manage it through this video analytics area. Then there are commercial transportation is very well known. ADAS is well known in the cars, and when you look at the buses, it can help how the driver is driving the bus or the train, and so on and so forth. Government and education can also be used. How the children are accepting the teachers' directions, and so on and so forth. So this is a huge market. The bottom line is a huge market, and we need to focus on that. Here are some use cases, right? If you look at city, state, and federal, right, one of the big thing is that how the emergency response. When you want to have an emergency response, like if you're watching a state highway and accident has occurred, then a quick alert can come to the fire station and to ambulance to rush there. That will be one of the areas. So it is regarding the safety and surveillance of the public facilities. Like if you have a concert, cameras can monitor and identify any wrong behavior, and so on and so forth. When you go to finance and banking, there are people. It can count how many people are there, how many lines are there. Can we do something about it? It can talk about whether the people who have a real account in that bank are there. If there is no, if they find somebody else, the security officer or somebody can go and inquire why their purpose of being there. Next is the industrial. I talked about the machine vision, right? Asset inspection is one of the big deal in industrial, besides making sure everything is working fine. Second area is the repair of equipment, which is through augmented reality. These cameras are used. Casino and gaming are very similar to other areas, right? Again, they are looking for people who are cheating there. Transportation is very well known, like ADAS and traffic, people, and so on and so forth, pedestrian movement, and everybody. That's another area to is a usage. Then you look at a home and retail surveillance. I talked about it. Robotics is very important. I visited a Tesla car company, and I saw they have robotics in shaping the car, and there is a camera which is monitoring it, and this is a very big use. And lastly is the drones, which is used for not only emergency response, but for asset inspection. Like for example, if there's an oil pipeline which is 100 miles or more than that, then you can fly a drone to see if there's a leakage or not. Even if the sensor detected, it is also likely that sensors may be faulty or things may not. So that's the one of the things. Okay. Now I'm going to go and talk about this city light, which is an intelligent city light. It has a camera, it has various sensors, and it can really help in managing the congestion and seeing. The city can monitor everything through this light. So next one, I'm talking about the intelligent transportation. Here you can see there's a camera which is outside. There is also camera inside. There are various cameras inside which are monitoring various equipment in the train, the driver of the train, as well as the passengers. And the front camera is really checking, really making sure the track is fine and the external environment is right. And the internal cameras are making sure the pilot is really awake and he's driving the train right. Here is the oil pipeline surveillance. Besides drone, you can have the cameras put at different point of observation where you can see what is happening there in this pipeline. So this pipeline is really monitored by video cameras besides other sensors. There may be infrared cameras also to detect leak and any intrusion, right? So if there is a unauthorized person comes near to pipeline, this can detect and can inform. So let's talk about the new challenge. So when people were using video cameras, I mentioned they were manually monitored. With video analytics, you still have those screens, but the thing is here that people can now know when the problem is occurring. If there is a problem, if there is a intrusion detection, if there is an anomaly, the video analytics will detect that, alert the operator, an operator that can go to display screen and check it out. Now, to implement this solution, you can implement a immediate response very close to the edge where the cameras are. Then you can have a kind of management like where you have more time, you want to manage and provision that response, you can do it a little farther. And then if you are looking for really a policy kind of things, then you do it in cloud. So what I'm trying to say, one of the big challenges that where you want to implement various functions of AI. You want to do it fog, you want to do it cloud, or what you want to do at the edge. So this is one challenge. Second challenge is that what kind of cameras you need to put and how many you need. And can that be supported by the infrastructure? Third challenge will be what is the latency? What is the throughput? Can the platform handle it? How much time will it take to identify and locate the object? Because if you take more time, then incident has already occurred. Right? Lastly, to do all this, what kind of platform you require at different places. And then of course data storage is part of that. To solve these challenges, as I mentioned, we believe in modeling and simulation. So end-to-end, if you can do an end-to-end modeling and simulation, it will help you address the challenges. So let's talk about the technology which can help you model and simulate. It is called Intel COFLUENT technology, and it's a system-level modeling and simulation technology that allows you to predict end-to-end IoT system, network behavior, and optimize performance. It allows the faster innovation. So what you do, this is a technology, I'll go later. It's very easy to enter the things in a block diagram, graphic way, and then you can start simulating. You can create your test bench, you have a model, and then you start having the results, and results will be plotted in a graphs, and the way, if you want to use different tool, that will create a CSV file, and you can do it. So if you are able to do that, the value proposition of this tool is that you can do very fast innovation. You can do a lot of what-if analysis, scenario analysis very fast. Second is you reduce the cost. If you are designing an equipment or designing a chip or designing a board, then what happens, since you are able to know your architecture and able to make right decisions, then you are able to follow that from each point of implementation, and that way you don't have many errors and you reduce the cost. The faster TTM is the reason because you don't have to redo many things. You can analyze the whole architecture and you know when you can do the things, what already exists, what needs to be designed, and how they need to put together. And these pieces can be divided into various different projects which can be concurrently implemented and put together, and that way you can do it much faster. Let's go to the benefits of this technology. This technology has benefits at different levels. One, at a user level. Second will be at ecosystem level. And third, I will talk about the technology, how the technology provides the benefit. So first talk about the user level. This will help in quick dimensioning, capacity dimensioning. This, let's say you have already implemented an infrastructure and now you want to hang more cameras to it. This technology can help you. Can you do it successfully? If not, then what do you need to change? Do you want to change certain algorithms, certain procedures so that it can fit in that analysis? Second, you can predict the workload performance. Let's say you are doing an image recognition, identification and recognition, and that you want to know how fast it can do it, how many images it can do it. This can do that part for you. Last one, the next one is the resource utilization. While you do that, it can take all your resources and tell you in a graph or bar chart how much they are used, at what point they are used, how much. And lastly, it can help you decide response time, latencies, and decide your infrastructure topology. If you can change the topology and change the effect on the performance, latencies, resource utilization, and so on and so forth. Now, who can really make use of it? One is the system developer who can do all these things, right? Or the architect for putting the infrastructure. Next one are the various suppliers. So let's say, for example, system providers. They can see the end-to-end solution, which is done by a solution architect, and they can optimize their piece, which they are supplying. The network operators who provide various communication technologies, they can understand how it is used and they can provision that kind of bandwidth capacity for you. Next one will be some of the gateway providers who can estimate how many gateways are required, what should be configuration, and what will be the load they can handle. And last is of course the edge device manufacturer, where they can get their specification developed from this. One point I want to make, from this technology, once you model and simulate, and now you want to decide to create a specification, this generates a Word document with figures, state diagram, everything. You push the button. Third point, the next point I want to say is that it also provides you a system C model as an output. So you can take it to your next tool in implementation cycle and you can implement it. Or if you want to do more analysis, then you can take to other tool and do that. Technologies. This one uses actually Eclipse IDE technology. It allows you to enter the block diagrams, timing, power, annotation, and you connect the pieces, just like a Lego piece. You put them together, connect them, and then should work. And each block you can define what it is doing in C, C++ algorithm, and you can decide what algorithm to use. You can change your algorithm, and so on and so forth. Lastly, in this area, the performance is predicted using analysis chart or latency, everything. They generate beautiful looking charts or the charts which are very beautiful. There are customers who are using right now in designing their systems, and they are using this one vigorously for simulating their various pieces and predicting their performance and optimizing their performance. And there are thousands of simulations in hour or 2 hours. So that is to give an inflection point to understand where is the where they should set the buffer point, how much buffer should be there, what should the bus speed, and so on. I will go to the next slide. Here are the usages. Hardware people can figure out what CPU, what memory, what IO configuration they can use. Infrastructure folks can figure out what should be the topology of memory. Should they use SSD? Should they use NVRAM? Should they use 3D crosspoint? Because there's a price point allocated to it, and how much to use. That's another thing. Do you want to have 3-tier, you want to have 2-tier, or you want to have a single tier? Network topology. Now there are many technologies in network. Of course, the most prominent is Wi-Fi and Ethernet. But then there are so many edge device technologies like LoRa, like Modbus, and so on and so forth, Zigbee, and so on and so forth. It helps you decide which one will be better for you. Then throughput and delays and power with respect to those areas, right? Customer engagement. So this is a very interesting area. Some of our customers have used this particular product. They created their own system, and then they modeled the customer environment with their system and proven the value that their system, their outfit is better suited in their environment, and they're able to get the better immediate results from it, design wins. So you can they have used it for ROI analysis, whether you want to scale up or scale out or scale wide. Those are the things they are able to do it. And this has been in conjunction with a marketing team and the architecture team. Marketing position, you can take your product and simulate that as compared to your competition, and you can decide where you can position your product, right? So for IoT, this is very interesting. IoT is just not one product, many products. So you can take your solution and compare it against the other solutions and see where you put it and how to price it, how to sell it, and so on and so forth. And last, of course, is time to market. It really improves the team collaboration. It helps you make decisions early in the product cycle, and these are the main messages of this technique. So I want to talk about video analytics, how you can surveil and secure your high values. So here is a case study. It was done recently. We assume there are 32 cameras which are 1080p, and they're each are generating about 15 frames per second, and they are mounted at different places. And you can assume a oil refinery, and some are put in a refinery area, some are at the gate, and some are in the lobby, and so forth. There are 2 cameras which are high priority, and the reason why they are high priority, they have been put at a place where the oil is coming into the refinery, and they want to make sure, and there is a gate there, they want to make sure that nobody comes in, or whoever comes in is authorized. And if something comes in, they want to make sure they take immediate action. That's why these are the 2 cameras which are high priority. 13 cameras, other are low priority because they are monitoring mundane things where things cannot go wrong and they don't have to take action immediately. Things will go wrong, but they will not go very quickly wrong. So they can afford some time delay. We also assume the 5 images per frame. So we said 5 average images can be there in a frame, which we need to detect and we need to analyze. So here is the Edge platform. This platform actually this is a system representation. How it is implemented, we'll talk about it later. There are cameras connected to a wireless or wired network, and that comes inside to decoder. And decoder that decodes it, we scale that image, and then we figure out what is the region of interest. And once the region of interest is decided, then we go and start analyzing that image. We set 5 images, 5 objects per frame, average. So we first identify the object, and then we recognize the object, what it is, and then we store it or put the analytics and send the information to the object. All the frames which are analyzed and the frame which are not analyzed, they are all stored in the storage area, and and then through the wired or wireless network, they are sent to the cloud or through the fog or the on-premise computer. So this platform, this is just one platform. Assume that sitting on the edge, and the similar can be done in the on-premise server, or it can be also implemented somewhere in between. The biggest challenge here is that how should it look like? What should be the CPU? How do we do the scaling in region of interest, right? Operation. How do we do the object identification, object recognition operation? What algorithms to use? What kind of component to use? That will be the challenge. And then based on that one, we can figure out how these cameras can be provisioned. One other thing I want to point out, that whatever we are doing, we should display on the camera. So we store the data, we also send it to for the display. Another thing is that, these days it's very common that people like to have in their mobile device all, so they can view the picture, they can view the camera results, or they can study the thing. So we do have a provision for transmitting the information. So moving on to the next slide. Sorry, before I leave this slide, I want to mention that yes, all these things which you see here are implemented in a platform, and what we decided to do is that take a Skylake platform and implement certain function of this, like decoder, scaling, right? Those kind of information on the Skylake platform, right? And there will be some we do in FPG, like region of interest, object identification, object recognition, we do in FPG. And then we model all this and see how many frames per second we can process. Do we need to change any algorithm in our region of interest? How we are discarding the frames? How much is the latency in getting from the time the camera registers a frame or object in its frame, and by the time we recognize it, that's the latency, or how much time it takes, right? And then we also looked at it, how these resources are utilized, right? The big challenge is that you want to balance your platform, right? So if you change the workload, if you change you said, well, I'm not going to identify and recognize here, but I want to just do the region of interest and pass on this one to the fog, right? Platform will look very different and will be very simple. So depending upon the workload, you may add the things more or less, and that you can simulate in this particular platform. So moving to the next slide. Here is the one we modeled it, and after that we ran the simulation. Here are the total frame processed over time, right? And the reason why we did not give a scale because we wanted to remain a little bit thing, but you can assume this is about 5 seconds what it is for. Next to that one is what are the frames we have dropped, which we did not analyze, but they were all recorded, they were all stored. So the number of frames recorded or analyzed and number of frames dropped, total gives you total storage capacity you require at your edge. Next is the camera latency. So as I mentioned, there are 2 cameras which are high priority, and there are other cameras which are lower priority. So here we plotted a graph for 2 high priority cameras and then 3 for low priority. If you look at the bottom of your screen where there is a green and red color, those are 2 the high priority cameras, and you can see the latency is very low, and it's really processing each and every image from that. And if you take the other 3 ones, right, these 3 cameras, you see the latency goes up, keep on, because things keep on piling, and then we go back and we say clear the frames and let's start again, right? And this way we are able to meet all the requirements. Assume that you don't want to do that. You don't want to really clear it out, right? Then in that case, you may have to change your resources. So let's go to the next chart where it shows the resources. Here are the resource utilization. The red color is the one which shows our CPU, Skylake platform, how it is performing. If you look at the light blue color, this shows actually how is our object identification and recognition FPGAs are performing. And the last one is the one which detects the region of interest. That's the one which it tells you that how it is doing that. Okay, so if you look at region of interest, right, that's getting saturated very quickly. So instead of FPGA, you may decide to use other components to increase it, and that's why we tried it that too also, and that worked perfectly. That can also work perfectly. But here we are just showing that you can really analyze all this, and then you can move on. Correct. Moving to the next chart. So let's say you have a resource utilization. You get something there, but you want to make sure that resource which is showing that it is fully utilized is really indeed fully utilized. So here is a chart where you can see how these components are utilized really. So if you look at this one, the red color shows that it is working. White color means that when you see the white lines, means they're waiting, or there is a they are not working full. And if it is yellow line, it is waiting for something. Right. So this is the way you see whether your algorithm or your function, how it is performing, and you can balance it. And if there is a criticality, it will also, you can look at this one and fix your circuit, fix your model according, or balance your model. So you can find out what should be your processing throughput, how many images you can process, what is the latency, how fast you are processing it, what is the latency, how your resources are utilized for given workload. Then you can also then know exactly how each component is working. Can you change the configuration, or can you change the circuit to make it faster or better? So look here. We said these are the challenges. How many cameras, right? We could model everything. So now we could answer how many cameras we can connect. What should be the network topology? What should be latency, and what is the throughput? Where we can put the critical functions? What kind of component we require? We know the Skylake platform. We know FPGA on ROI, region of interest, is challenging. It is workable, but if you put GPU or GPU, that may be expensive. But you can do that. You can get a high capacity. You can do a better image. Right? How much data storage is required, and then where you can put what kind of function. At least you know some AI functions which you put on the edge, how does it look like? But once you have done the edge, you put the fog and then cloud, all three models together, you can balance it. I just showed here only one side of it, but we do have other pieces also. Now I'm going to say that, well, let's say you want to start and want to use these models, right? How to generate your models. So we have a generic IoT library, which I want to show here. We have various kind of sensors. We have all types of wireless channels. And if you see on your left-hand side, it's a menu which tells gateway, start Bluetooth edge network, cloud storage, cloud uplink router. All these are the generic components which are available. You can pick them. You can read their details, and you can modify them to adapt to your need. And then you can connect them quickly and start running your simulations. So here is the one here is what I wanted to talk about it, how you can create a, a model by which you can really balance all the areas of video analytics solution. So there are other platforms which we have, and I will go briefly about them. So one is that about SOC. It's very much used by many customers of ours. It is for hardware IP modeling. Architects mostly use it, and they get the benefit. They get really good timing, good performance results, and then they connect to their development flow, code generation, specification generation for giving it to their third party. All they do. Then the modeling capabilities, I mentioned that you can see there is a model shown on a top right block that you can enter the architecture block very quickly. You can do the timing annotation. You can also do C++ and MATLAB code behavior description. You can simulate chart for latency, throughput, hardware usage, software states, custom matrix. You can do all those things in this one. Here is something which is a complete setup picture. So you have a IP. You can, so as I mentioned, that you can generate the model and you can take it to your programming side, like for example virtual platform, which is Cemix for Intel. You can take this model and then take it directly to Cemix to develop your software. You can do that. And this is one view. We have a test bench. We have an actual IP. Then we put a device program view in it. You can test everything out. Once it is tested, you generate the model in the Cemix format, and it integrated Cemix tool and can start developing your software. So here is again the test bench validation system which we talk about. Let me go through the big data. This is only a services. It's not a product which is available outside. So what is the big issue there? How you define the cluster? That's a big issue. Big data cluster design is a big challenge. What should be your hardware utilization? Can you predict your system scalability? Can you predict the size? Can you optimize your software stack as well as hardware resources? Predict the system performance and minimize cost. So here is something which we have done. We have worked with few customers where we have explored the system architecture, performance diagnosis we have done, market positioning we have done, and we have accelerated the customer engagement. So what kind of workload coverage we have? We have a Spark Streaming, Cloudera Impala, Hive, Hadoop Reduce, Spark, Apache HBase, OpenStack Swift, Hadoop HDFS. All these workloads we work on, and we can certainly help any customer in optimizing it. Now, why I'm bringing it up? End-to-end solution requires going to the cloud, and cloud mostly is now big data. When you do the training of your model, you take it from big data and train it. And of course, Intel Cafe is known for as a trainer, and there are many algorithms are used there. Okay, so if any of you have question, feel free to ask me. Somebody is asking, is this platform available in SDK? No, I do not think so at this point. No, it's not available on SDK right now. But if you have more questions, feel free to ask me or send me an email, and I will be happy to answer. Thank you.